guys, welcome back to my YouTube channel. Today I'm going to be showing you how to solve a linear system using the substitution method. So as the name substitution implies, what has to be done is an expression has to be substituted into one of the variables in order to solve for the system. So first step, what I like to do is I like to label my equations so I keep things nice and organized. So equation 1, this is equation 2. And then what I have to do is I have to go into one of these equations and isolate for one of the variables, either x or y, right? And then after I isolate for it, I'm going to substitute it into the other equation. So here, let's isolate for x here in equation 1 because there's no coefficient from x, so it makes it a lot easier. So I'm going to do this equation. So I'm going to work with equation 1. So I'm going to write from 1, right? 1 is basically x minus 2y equals 7. I'm going to isolate for this x. So to do that, well, we have to look at what's with the sign of x, right? Negative 2y, well, we want to get rid of this, right? We want to keep x by itself on one side, so negative 2y, we need to get rid of that. And to do that, the opposite is going to be positive 2y. The opposite is going to be positive 2y, so I'm going to add 2y on this side. And whatever I do on one side, I must do on the other side, so I'm going to add 2y on this side as well. It's negative 2y plus 2y, so these are going to cancel. So negative 2y plus 2y, they're going to cancel because negative 2y plus 2y is just going to be 0. So we're going to be left with x right here. So it's going to be x is going to be equal to 7 plus 2y. And there we have it. We got our x. Now we can label this as equation 3. And using this equation 3, we can plug in equation 3 into equation 2. So why not equation 1, you may ask? Well, it's because that we took equation 1 right here and we rearranged it and made it into equation 3. So if you're plugging it back into equation 1, it's like it's the same equation you're using. We haven't even used equation 2 yet, right? If you plug it back into equation 1, it's not going to work. I can guarantee it. You must use the equation 2 because we haven't used it yet. So we are going to plug equation 3 into equation 2. So doing that, we are going to have to plug in this expression here, right? So let's write in equation 2 first. So I'm just going to copy equation 2. And what we have to do is we have to substitute the x, right, in equation 2. This is equation 2, by the way. Same thing as this equation here. But we have to substitute this x with this expression right here, right? So we're going to substitute that in. So 3 times 7 plus 2y. And put brackets here because this is 3x, right? 3x is 3 times x. So it's 3 multiplied by this entire expression, which is x, right? X is equal to this. So I plug that in, then plus 4y is equal to negative 5. And then from here, we can see we only have one variable, y, right? So we're going to have to solve for y, right? We have one variable now. We don't have two variables, so we can actually solve and get like a number for y, which is great. So let's do that. And first step before we do that, we have to use a distributive property, make things a lot easier for ourselves. So 3 multiplied by 7 and multiplied by 2y, right? Multiplied by each of these terms. So 3 times 7 is 21. 3 times 2y is 6y. And here it's plus 4y right here. So this is equal to negative 5. Now here there's 21 plus 6y plus 4y, and we notice we have like terms. So 6y and 4y, these are like terms. So we're going to combine these like terms, and 6 plus 4 is 10, so it's going to be 10y. And here it's 21, so just copy the 21. and then here it's equal to negative 5. And then we can see here we have 21 plus 10y, and we want to solve for a y, right? We want to isolate for a y, and we have 21 and the 10 here, and we want to get rid of them so we can leave y alone on its own side. So what we have to do is get rid of them, right? So first we have to get rid of the 21 because we have two separate terms, so it's better to get rid of the 21 first. And this 21 has an invisible positive sign in front of it, right? Usually it's not written, but the invisible positive sign is there. So it just means this 21 is positive. So that means we have to apply the opposite, which is subtraction, right? So subtract 21 and 21 minus 21, well, that's going to be 0, right? Ideal, because we can get rid of it and make it a 0. So it's just going to be 10y that's left, which is equal to negative 5 minus 21. And I did negative 21 on both sides because we need to balance out the equation. So negative 5 minus 21 is going to give us negative 26. And then here we have 10y, so 10 times y, right? 10y is the same as 10 times y, so the opposite of that is to divide by 10 here on this side, and then whatever we do on one side, we must do on the other side. So I divide both sides by 10, and this 10 and this 10 will cancel, and we're left with y, which is equal to negative 26 over 10. And here we can see that 26 and 10 are even numbers, so since they are even numbers, it just basically means that we can simplify as fractions, so we can divide by 2 here and divide by 2 here, and we will get negative 13 in the numerator and 5 in the denominator. So y is equal to negative 13 over 5. Now we want to find x, right? When we solve for this system, we are trying to find x and y, right? That's our goal. So we're going to do that. And we know y, and we know equation 3 is x equals 7 plus 2y. So all we have to do now is we can substitute this back into equation 3 to get to x, right? Because x is very nicely isolated for us, so we can just plug this y back in here. And we wouldn't plug it back into equation 1 or 2. I mean, you could, but this is easier. It's a lot easier because x is already isolated for us. So we just want to take the easy route, right? So then we could solve this equation quickly, instead of plugging it back in here and doing all the moving to one side and the other and isolating. But here it's very nicely isolated for us, so let's use equation 3. So I'm going to write in that we're going to substitute y equals negative 13 over 5 into equation 3. And equation 3 was this, so we're going to write that. Equation 3 was x equals 7 plus 2y. X equals 7 plus 2y. Basically, I'm going to plug this here, right here, into y. So basically into this y right here, so x is going to be equal to 7 plus 2 times negative 13 over 5. And then that's going to give us 7 plus 2 times 13 is going to be 26, right? And then we have a negative here, so it's negative 26 over 5. And then we have to, we see a fraction, right? So let's basically get a common denominator so we can add the fraction. So this is basically 7 over 1. So multiply by 5 here, multiply by 5 here to get a common denominator. And 7 times 5 is 35. 1 times 5 is 5. This is minus 26 over 5. Well, you're adding negative, right? So it's the same thing if we just don't write the plus sign. Basically, we're subtracting when you are adding a negative. So 35 minus 26 is going to give us 9 over 5. And here we have solved for our x. This is our x, right? And this is our y. So I'm going to write in that. Therefore, the solution is going to be x is equal to 9 over 5, as shown here, right? And then y is equal to y is equal to negative 13 over 5. And you can also present your solution as coordinates like this. 9 over 5, negative 13 over 5, like that. And basically, if you were to graph these two equations, you will see that their point of intersection is going to be this coordinate right here because it satisfies both of the equations. So now say we have a linear system that looks something like this, and we want to solve this using substitution. I mean, it's not really ideal. You can solve this using elimination, but let's say if you were asked to solve it using substitution, okay? And to solve this using substitution, we will apply the same steps. So first, let's label these equations, keep things nice and organized. And then what we have to do is we have to see that we have to take basically one of these equations. It could be either equation 1 or equation 2 and isolate for one of the variables, either x or y. So, well, I mean, they're both kind of equally as challenging, I guess. I mean, let's do equation 1 this time and isolate for y here, the 3y right here. So let's copy equation 1. So from 1, which was basically 7x plus 3y equals 6, we are going to isolate for this y right here. So here we have 3y, right? Let's get rid of the 7x from both sides. So we're going to subtract 7x from both sides of this equation. So 6 minus 7x. 7x minus 7x is going to give 0, so cancel. This is 3y, which is equal to 6 minus 7x, like that. Okay, so we're isolating for y, just like how we did before. We're isolating for one of the variables. And here we have 3 times y, and the opposite of multiplication is division, so I'm going to divide both sides by 3 to get rid of this 3 right here so we can leave y by itself. So y is equal to 6 minus 7x all over 3, and we can basically apply this fraction to each one of these terms. So it's going to be 6 over 3 minus 7x over 3, and then 6 over 3 is the same as 2, so I'm going to write 2, and then 7x over 3, well, can't really simplify it, so just going to be 7 over 3 times x. So we have found our y. And we can label this as equation 3. And then labeling that as equation 3, we can take equation 3 and plug it back in to one of these equations, but it has to be equation 2, not equation 1, because from 1, we basically found equation 3. So equation 3 is the same thing as equation 1, so we don't want to basically repeat that. We have to use equation 2, which hasn't been used at all yet. So we are going to substitute equation 3 into 2. So sub 3 into equation 2. And let's copy equation 2. So I'm just going to copy this whole thing here. 5x minus 9y equals 11. So 5x minus 9y equals 11. And I'm going to substitute this right here. And it's y equals this. So I'm going to plug it into the y. Okay? So I'm going to plug this into y. X minus 9 times 2 minus 7 over 3x, right? This whole thing is our y from here. I'm plugging it in, just replacing this y with it, right? And this is going to be equal to 11. So now from here, we can see we can apply distributive property, right? This negative 9 can be applied to each of these terms. So let's copy 5x. So negative 9 is going to be multiplied by 2, so negative 9 times 2, and then we have negative 9, which is going to be multiplied to negative 7 over 3x. So yeah, it's very important we don't forget this negative, okay? So basically taking this entire thing, taking in fact the sign as well, then this is equal to 11. So we're basically now we're basically trying to solve for x, right? Because we only have a variable of x, and we could get x is equal to some sort of number, right? Because we basically plug in this into y, and so y is not there anymore. I mean, like, this is y, but we have y in terms of x right here. So basically we can just solve for x. So yeah, that's what we are doing. So 5x, we're going to simplify, minus 9 times 2 is going to be negative 18, and then we have negative 9 times negative 7. Well, a negative and a negative makes a positive, so it's going to be positive. 9 times 7 is going to be 63, so this is going to be 63, and then over 3, and then the x right here. It's going to be equal to 11. And then from here, we have, these are our terms of x, right? This is our constant, so I'm going to move this to the other side. So I'm going to add 18 on both sides because this is a negative 18, so the opposite is going to be positive 18. So this and this are going to cancel, and we have 5x plus 63 over 3x. 63 divided by 3 is 21, so we have 21x, right? Don't forget that x. And then 11 plus 18 is going to be 29. And then from here we have like terms, 5x and 21x are like terms, so this just gives us 26x, and this is equal to 29. And then here, 26x, we know 26x is the same as 26 times x. So 26x is the same as 26 times x. So the opposite of that is going to be divide, right? Because we're multiplying here 26 times x, but the opposite of multiplication is going to be division. So divide both sides by 26, cancel this out, and we can isolate for x. X is 29 over 26. So now that we have found our x variable, we now need to find our y variable. So we can see, well, we can plug it back into these equations, but it's going to be a lot more tedious. We're going to have to isolate for y and all that, but we can plug the x back into this equation, equation 3. It's actually a lot easier to do that because our y, as mentioned before, has been isolated for us already. So once we plug this in, we can just simplify this and we will get y. So we are going to plug in, so we're going to sub x equals 29 over 26 into which equation? Equation 3. So plugging that in to equation 3. So equation 3 is this, so I'm going to copy that. So y equals 2 minus 7 over 3x. 2 minus 7 over 3x. So I'm going to plug this x value in here. So it's going to be 2 minus 7 over 3 times x, which is 29 over 26. And then we can simplify this. So this is equal to 2 minus, we can't really simplify these fractions, so let's just multiply them together. 7 times 29 is going to give us 203. 3 times 26 is going to give us 78. It's shown here, right? And then we have, we have to add these two together, and to do that we need a common denominator. Recognize this as 2 over 1, right? 2 is the same as 2 over 1 minus 203 over 78. And then I just have to multiply this by 78 in the denominator, and I have to do it in the numerator as well. So I'm going to get 2 times 78 is going to be 156 over 78. This is 78, this is 156. This is minus 203 over 78. And And then since we have a common denominator, we can basically combine these fractions together, subtract them, so I can do this. Same denominator, which is perfect. So 156 minus 203 is going to give us negative 47 over 78, which is the same as negative 47 over 78. And there we have it. We have found our y variable. So we have found our x and we have found our y. So therefore we can say that our solution, we can write it as x equals 29 over 26, 29 over 26, and y equals this here, right? Because this was actually our y. So equals negative 47 over 78. And we can also write it as coordinates, so 29 over 26, comma, negative 47 over 78. And this is our solution. Okay, so this is the end of the video. If you enjoyed it, feel free to give it a big thumbs up. And furthermore, if you love my content, feel free to hit that subscribe button. And also let me know in the comments down below what you think about this video. I hope to see you next time for another math video. Bye!